Okay, for C, we are still looking at savings, but now instead of having a savings account where we just put in something and then we're just going to let it sit, now we're going to talk about what's called a savings plan. So a savings plan, we're going to submit money on a regular basis. So we're not just going to make one thing and let it sit. We are making multiple deposits. So when you look at the question, that's what you're looking for to tell the difference between what we did in 4B and what we're doing here. So in 4B, everything was just a single deposit, put it in, let it sit. Now we're making multiple deposits or payments. So for example, suppose you deposited $60 per month into a savings plan for 7 years, and at the end of that period, your balance is $21,200. What was the amount you earned in interest? So trying to figure out which equation we're dealing with. Here we see that we deposited $60 per month. So because it's not just depositing $60, it's $60 per month, this tells us that it is a savings plan. Of course, you also have the word savings plan, but those words aren't always there. So let's just go ahead and we can answer this question because we don't really need a lot of information for this. So it says we deposited $60 a month for 7 years. At the end of the month, it tells us that our balance was $21,200. What was the amount you earned in interest? So in general, for any of these that we're looking at, our ending balance is going to be the amount that we put in, which I'm going to call the principal. So all the money that we put in plus all of the interest that we put in. So that's just any of it in general, right? So if we want to know for this one the amount you earned in interest, we want to know what this is. So our interest is going to be the ending balance, our accumulated balance, minus principal, what we put in. So in this case, our accumulated balance, it tells us, is $21,200. Now principal is not 60. We put in $60 per month. So let's do our color. So off to the side here, we need to figure out what our principal is. So we did $60 per month, and we did that for 7 years. So we need to know how much this is. We need the dollars per 7 years, right? So $60 a month, and we do that for 12 months each year, and we do that for 7 years. So years cancel, months cancel, and we're left with just dollars. So $60, so how much we put each time, how many times per year, times the number of years. And that is going to give us 5,040. So over here we take the 21,200 which we have in our account minus the 5040 that we put in, and we get total interest of $16,160. Okay, now the savings plan formula is a bit more complicated. Now this one is on the formula sheet for when you take the test, so you do not have to memorize it. You just have to know when to use it and how. So for this one, because we're not just putting it in once, we don't necessarily have a principal. We're going to use PMT for payments. So PMT then is going to be your payment amount, however much you deposit. So either payments or deposit. APR is the same thing as your annual percentage rate. Of course, you put it as a decimal. N and Y, again, mean the same thing as previously. So really the only thing different here is instead of having a P, you have a PMT for payment, and then you have a much more complicated formula. N, again, is going to be the number of payments per year. So here, where before the N was the number of compounding periods, and here the number of payments, again, just because compounding, you put money back into principal. Here, you're putting your money plus interest into the account. So your N is basically the same as the number of compounding periods. So if you see the word compounding in any of these savings plan, you can just kind of ignore it because the compounding periods are going to be the same as your payment periods. And of course, y is for the number of years. So in general, the questions you'll be asking, so what is my savings plan balance if my payment is so many dollars each, and for month, year, etc. If it's deposited or invested at an APR of so many percent for y years. Doing it in your calculator. Again, just like we did for section 4B, I want you to focus on getting all of everything past the parentheses. And if you don't want to memorize, like this is a lot to memorize. So basically what we're doing is we're going left to right, top to bottom. So we start with our outside parenthesis, and then we start with another parenthesis, and they do our 1 plus, and here we have a fraction. So we do the top, our APR divided by our n, and then done with the fractions, we move on. So we have a parenthesis. And I get up into the exponent, you're going to have to put the caret in parenthesis, n times y parenthesis. Now, for some calculators, you have to push like a right arrow button here, but that's only on some calculators. If you have the one that is listed in the syllabus, you don't have to do that. You just do the n parenthesis minus 1 parenthesis, and now we're done with the top of our fraction. So then we do divided by, now again left to right, we start with parenthesis, now we have a fraction, so we do top to bottom, APR divided by n, a parenthesis, and you're done. So it's a whole lot of stuff going on. So just remember, it's left to right, top to bottom. Or if you have some of the fancy calculators that actually like put it into a fraction, then that can help. But if you don't, then don't worry about that. So you finish all the top, and then because we have the payment, you're going to take your payment and you're going to multiply that by your answer, just like we did before, and hit enter. So let's look at another example. Find the savings plan balance after 24 months with an APR of 5% and monthly payments of $125. Okay, so because we're making monthly payments, this tells us that it is our savings plan. So if we want to know all of our variables, we have A, PMT, APR, N, and Y. Okay, so again, it's either going to give you A or PMT. In this case, they give you monthly payment. So you don't know your A, you know your monthly payment is $125. Because it is monthly, my N is going to be 12. My APR has APR 5%, so my APR is going to be 0.05. Now here it gets a little bit tricky on this question because we don't have a number of years, we have a number of months. So notice, just like before, when we had the NY in parentheses, or in the exponent, this, right, is going to be the number of periods total. So N is the number of times per year times the number of years, right? So here we have the total months, which is what we're doing as our time period, right? So in that case, they actually give us NY. Now, if you want to, you can convert. Okay, so if you can't remember that this can just go into NY, you can say, okay, so it says 24 months. I need to know the number of years. So you're going to convert 24 months to years. So we know that 1 year is 12 months, and we have 24 months. So this is 2 years, which means my Y would be 2. Okay, either way, it's going to work. It's just one requires a little bit more math. One requires more logic and reasoning, the other is more math. So whichever one you feel most comfortable with. So then we just plug and check. So we have A equals my payment, and it's going to be 1 plus my APR, so 0.05 divided by n is 12. Raised to the n times y. So here, since we know ny, we can put a 24 here. If we didn't know that, we would have our n is 12 times the y, which we found over here is 2. Actually, probably would put it in as 12 times 2. Okay, n times y. Okay, and then finishing off, we have a minus 1. And that is going to be divided by my APR again, so 0.05 divided by n. Okay, so I'm going to put everything from the parenthesis on in the calculator. And I end up getting 125 times and I didn't write that down, so I have parenthesis 1 plus 0.05. So I get 25.1859 and so on. So then I have that in my calculator, and then I multiply that by 125. And I get an ending balance of 3148.24, rounded to the nearest cent. Okay, example 3. A friend has an IRA with an APR of 6.25%. She started the IRA at age 25 and deposits $100 per month. How much will her IRA contain when she retires at age 65? Compare that amount to the total deposits made over the time period. Okay, so again, figuring out first what kind of equation we're looking at, we see that we are depositing $100 per month. So it's not just one time, which means we are in the savings plan. So looking at our variables here. So again, they're either going to give us A or PMT. In this case, they give us our payment of $100 per month. Then we have APR, which we said was 6.25, so 0.0625. And then N, we are making $100 per month, so my N is 12. And my years, they don't actually tell us the number of years, but it does say she started at age 25 and she's retiring at age 65. So the total amount that is going to be sitting there is the age she retires at minus the age she started, which is 40. So it's going to be sitting there where she's going to be depositing money for 40 years. So if we want the balance at her retirement, we have our payment is 100. Then we have 1 plus our APR, 0.0625, divided by my N, raised to the N, which is 12, times my Y, which is 40, minus 1, all over my APR, divided by my N. So I'll put everything from the parenthesis on, and then multiply by 100. And you would get $213,191.25. Now the total deposits made. So this is the total deposit. So this is our money, or what we can call our principal, right? So we said that our ending balance is going to be a principal plus our interest. Right? We are looking for this here. So right now we don't really care about the interest. We're looking at the principal. So to figure out the principal, we know that we take our $100 per month and we are going to put that in 12 times a year, and we're putting that in for 40 years. So this gives us $48,000. In general, to find the number of deposits, you're going to take your payment times your N times your Y. Okay. Now from here, we could figure out the amount of interest, which is actually a lot. You get $213 at the end. You only put in $48,000. It's a lot of interest. Okay, now let's look at planning ahead. So especially if you're saving for retirement, like in that IRA, you may have a certain amount that you want to have at your retirement. So now let's see how much we would have to put in every so often in order to have that amount. So just like before, we're going backwards. So instead of multiplying, we're going to be dividing. So again, you put everything in the parenthesis onward, but instead of having payment times, you're having your ending amount, your A, divided by that answer. So an example, so at age 35, you start saving for retirement. If your investment plan pays an APR of 6% and you want to have $1 million when you retire in 30 years, how much should you deposit monthly? Okay, so either A or PMT. In this case, they give us our A because we know what we want to have. So we want to have $1 million. And we are trying to figure out our payment. Okay, then we have our APR, our N, and our Y. APR says we have 6%, so 0.06. Here we want to deposit monthly. So again, this is also the wording that tells us we're using the savings plan. You're depositing monthly, so you want an N of 12. And you want to retire in 30 years. So my Y is 30. Okay, so I have the A is $1 million. So we have our payment times 1 plus my APR divided by my N, raised to the N times my Y, minus 1, all over 0.06 divided by 12. APR divided by N. Now, a lot of these are going to be monthly, but you might, for something we're going to be, it could be different than monthly. Okay, so you put everything after the parentheses. So we have 1 million equals our payment times, we put all that in, and we should get 1,004.515 and so on. Okay, so then I do 1 million divided by that answer. Which gives us our payment of $995.51. I'll write that a little better. Okay, so $995.51. So you have to put in that amount in monthly in order to have $1 million at the end of 30 years. Okay, example 5. At age 20, when you graduate, you start saving for retirement. If your investment plan pays for an APR of 4.5% and you want to have $2.5 million when you retire in 45 years, how much should you deposit monthly? Okay, so we're depositing monthly, so we're doing savings plan. We have an ending goal in mind, so 2.5 million. So you can either put 2.5 times 10 to the 6, because we know that million is 6, or you can go ahead and write it out. Either way is fine. It doesn't matter. Both ways will work in your calculator. So we have an APR of 0.045. We're making monthly deposits, so my N is 12, and we are letting it sit for 45 years. We're not letting it sit, we're depositing it for 45 years, sorry. And we want to know monthly payment, so we want to know our payment. So we have, I'll go ahead and show you the 2.5 times 10 to the 6. That's going to be your payment times 1 plus my APR divided by my n to the n times y minus 1. Know that these square brackets in your calculator, you're just going to put normal parentheses. And then 0.045 divided by 12. Okay, so we get our payment. All of this over on the right comes to 1745.992 and so on. So in your calculator for this next part, you just go ahead and type in 2.5 times 10 to the 6. If you want to stay in the habit of always putting the times 10 numbers into parentheses, that doesn't hurt. So 2.5 times 10 to the 6 divided by your answer, and you would get 1431.85. So if you want 2.5 million in this account, you'd have to put in $1,431.85 every month. Okay, example 6. Who comes out ahead? Consider the following pairs of savings plans. Compare the balances in each plan after 10 years. In each case, which person deposited more money? And which of the two investment strategies do you believe was better, assuming compounding and payment periods are the same? Of course, we're assuming that for every single one of these questions. So we have Juan and Maria. So Juan deposits $400 per month in an account with an APR of 6%, and Maria deposits $5,000 at the end of each year in an account with an APR of 6.5%. Okay, so we need to know how much they have after 10 years. So for Juan, in this case, we don't know our A. We do know how much we're putting in each time. So he deposits $400 each month. So my N is going to be 12. Go ahead and write that down. My APR is 6% for him, so it's 0.06. And we are putting this in for 10 years. So my balance is going to be my payment times 1 plus my APR divided by my N, raised to the N times my Y minus 1 all over APR divided by N. So put that in the calculator and I would get $65,551.74. So Juan has $65,551.74 in his account. Now Maria, she is doing $5,000, but she is only doing it at the end of each year. So she's only doing it once per year. So her N is 1. Her APR is higher at 0.065%. And again, she is at 10 years. So she is $5,000 for a payment. You have 1 plus 0.065 divided by 1, so only once per year. Raised to the 1 times my years, minus 1, all over my APR divided by N. So putting that in the calculator, I end up getting $67,472.11. So up to the end of the 10 years, Maria has more money. But just because she has more money doesn't necessarily mean it's going to be the better investment. Well, it could, right? So we talked before about how there's two different things you can look at, whether you can look at the amount of money you have at the end, or you can look at the total return. So we'll look at this too. So let's figure out who deposited more money. And we can use that to help us figure out the total return. So Juan. He did $400 a month. So that was 12 times a year, and he did that for 10 years. So he deposited $48,000 in his account over those total 10 years. Maria did 5,000 years, so she only did it once per year for 10 years. So she deposited 50,000. So Maria ended up depositing $2,000 more. And her account at the end is also 2,000 more. So it's pretty close actually. So let's look at the return to see which one do you think would be better. So to figure out the return, we're going to figure out the percent of the balance that is interest. So how much of my balance did the bank put in versus what I put in? So, all right, so the two different ways we did this before was we can either figure out the amount of interest and divide that by the balance, or we can figure out the amount that we put in, the deposit principal over balance, and then we're going to subtract that from 100. I'm going to go ahead and do it. Well, for Juan, I'll do it one way. For Maria, I'll do it the other. Okay. I cannot spell Juan, apparently. Okay, so for Juan, we want the percent of the balance that is interest. So first we need to figure out the amount that is interest. So our interest is going to be the amount that he had at the end. So he had $65,551.74. Subtract off what he put in. He put in 48,000. So his total interest was 17,551.74. So if we want the percent that is interest, the percent of the balance that is interest. So the percent that is interest is 17,551.74 divided by the balance of 65,551.74. And you end up getting 0.26775 or 26.8%. So Juan's return was 26.8%. Now let's look at Maria. Okay, so for Maria, we're going to do it the other way. So we're going to figure out the percent that is your principal first, and then subtract that from 100. So to find the percent that is principal, you're going to put the amount that she put in. So she put in 50,000, and her balance was 67,472.11. And that gives you sorry, my calculator is being a little, I didn't want to type my numbers in. Okay, so you get a 0.7410, which is a 74.1%. So then I'm going to take 100% minus the 74.1 to get a 25.9%. So Maria had a 25.9% return and Juan had a 26.8% return. So even though Maria had more money at the end, she also put more money in. So in this case, Juan had the better return. So we're going to say that his is the better, I'll use this color. He has the better return. Okay, last example. Will it work? Suppose you want to accumulate $50,000 for a college fund over the next 15 years. Determine whether the following investment plan will allow you to reach your goal. Assume the compounding payment periods are the same. So here, so they give us, we want $50,000. They give us a payment as well, right? So they give us both A and B. What that means is we're going to use this or this payment to see if this A is accurate. So are we going to have that $50,000 that we want? So We're depositing $100 per month, which tells us it's a savings plan. So our payment is $100 per month, so my N is going to be 12. My APR is 0.06, and my Y is, let's see, we're going to college fund over the next 15 years, so our Y is 15. Okay, so check my balance. We have $100 a month. So 1 plus my rate divided by my N, raise my N times my Y, subtract 1, all over APR divided by N. Okay, putting that in gives us $29,081.87. So if we did this plan, we'd only have $29,081 or $81.87, which is not the $50,000 that we want. So this is not enough. So if we wanted that $50,000, we'd have to change something, either deposit more in a month, deposit more frequently, or have a higher APR, or let it sit for longer, right? So something has to change in order to get to that $50,000. Okay, and that is 4C.